Okay, let's look at the limit of logs next. Alright, so assuming the base of your log is greater than 1, so a is greater than 1, then the limit as x approaches infinity of log base a of x is equal to infinity. And the limit as x approaches 0 from the right of log base a of x is equal to negative infinity. The limit as x approaches 0 of any log from the left does not exist. That's why it's only 0 from the positive side. Okay, so we're first going to look at solving some logs. So if I look at example 1a, I'm given log base 3 of 81 is equal to x, and I'm told to solve that. So that means I need to solve for x. Log base 3 of 81 equals x is equivalent to 3 to the x is equal to 81. You work in a zigzag pattern when working with logs. Does that make sense? So, very good. So, 3 to what exponent is equal to 81? 3 to the 4th is equal to 81, so x is equal to 4. Okay, so any questions on 1a? Okay. On 1b, I'm given log base 25 of 5 is equal to x, and I'm told to solve that. So what that tells me, if I continue in my zigzag pattern, is that 25 to the x is equal to 5. So, what would I have to do to 25 to make it be 5? It's going to be a fraction because I'm getting smaller. And I know that the square root of 25 is equal to 5. And square root is the same thing as a fraction of 1/2. So, x is equal to what?
1/2.
1/2, yep. Because my exponent is 1/2, so x is equal to 1/2. Okay, the second part of what we're doing is evaluating logs where you're adding. So we're using our rules for adding and subtracting logs. So evaluate log base 4 of 2 plus log base 4 of 32. And just like how there's weird rules with exponents, there's weird rules with logs. Whereas that if you're adding your logs, like we're adding here, you're actually multiplying your insides. So if I were to start by simplifying this and combining it into one log, 2 times 32 gives me 64. So this is actually like log base 4 of 64. Yep, so when you're adding, you're actually multiplying the insides. And your base just stays the same. And so this is like log base 4 of 64 equals x. So I need to find my x. So, yeah, I think it is. So if you do zigzag pattern, 4 to the x then is equal to 64. So then I need to figure out what my x is equal to. So what would I have to take 4 to, what exponent to make it be 64? 4 to the 3rd, yep, 4 cubed. So that tells me x is equal to 3. Because your x and your 3 line up in the exact same spot in your equation. So any questions on 2a? Okay, so if I look at 2b, I'm asked to evaluate log base 2 of 80 minus log base 2 of 5. And just like how adding logs is weird, subtracting logs is also weird in that when you're subtracting logs, you're actually dividing the insides. So if I were to make this be 1 log, I get log base 2 of what's 80 divided by 5? Anybody? 18 is close.
16.
16. Well, 80 divided by 5 is 16. So I get log base 2 of 16. And since I want to solve that, I have to set it equal to a variable, so equal to x. And then if I zigzag, I get 2 to the x is equal to 16. And so 2 to the 4th is equal to 16, which means x is equal to 4. Okay, so when adding logs, multiply the insides. Subtracting logs, divide the insides. The next thing that I'm going to look at is the limit as x approaches 0 of log base 10 tangent squared of x. Remember that our limit as x approaches 0 can only be done from the positive side, so from the right. So the limit as x approaches 0 from the negative gives us our first limit. And then the limit from the positive side gives us our second limit. And since we're going from the positive and the negative, we're covering both sides of 0. So it's okay to split it up into 2 separate limits. So then let's start with the limit as x approaches 0 from the negative. What did I tell you about that limit?
If it's negative, one of them's negative, I'm negative infinity.
Is that from the positive or from the negative side of 0?
Positive.
Okay, so from the positive side of 0, it's equal to negative infinity. Okay, what did I tell you that it's equal to from the negative side of 0? It wasn't in your notes. It was just something I said out loud. It is not 0.
Infinity.
It is not infinity.
1.
It does not exist. The limit as x approaches 0 from the negative will never exist on a log function. Okay, so from the negative side it does not exist. From the positive side it's equal to negative infinity. Alright, and then the last part of what you're doing today is you're going to be manipulating some logs. So we want to solve that for x. So I'm given e to the 5 minus 3x is equal to 10. First thing I have to do is I have to get rid of this base e. So I have to take the log base e of both sides. And what is log base e equivalent to? It has a special name.
Natural log.
The natural log. Okay. So these cancel, and I'm left with 5 minus 3x. Log base e is the same thing as the natural log, so ln of 10. So on the left, I'm left with 5 minus 3x. On the right, I'm left with natural log of 10. What's going to be my next step in solving for x? Nope, you're just going to straight solve for x from here on out. So subtract 5. Okay. So if I subtract 5, I'm left with negative 3x equals natural log of 10 minus 5. And then divide by negative 3. So I'm left with x equals the natural log of 10 minus 5 divided by negative 3. Okay, so when trying to get rid of bases, you have to take the log of that base. So if it's log base e, if it's e, then take log base e. If it were like 2, you take log base 2, etc. You guys are going to work through page 4083 through 18, 27 through 36, 47 through 52. We're going to work on this today and tomorrow.